All right, so welcome to 3.6 quadratic formula. This is the best lesson because if none of the other stuff made sense and you're asked to solve a quadratic, if you know the quadratic formula and how it works, you're guaranteed to get it right. You may be doing it the longer way, but this works every single time. Now, there's a couple of vocabulary words. I don't do a ton of vocabulary. One of them is quadratic formula, which we'll learn here in a minute. The other one's called discriminant. Again, we'll learn here in a minute. In the Big Ideas book, page 143 shows how the formula came to be. They basically took the ax squared plus bx plus c, solved for x, is all they did. So what's even happening? When we solve quadratics, basically we're asked to find where does it cross the x-axis. This one crosses twice. This one touches and therefore technically crosses once. I told my kids it's like stepping out of bounds. It counts as a touch. When we have something like this and it doesn't cross at all, we don't just go, oh, well, it doesn't cross, we can't do anything with it. This is where our imaginary numbers come in. We would have two imaginary solutions. Well, it doesn't cross, but if it did, this is what it would kind of look like. We've been mostly doing factoring. It only sometimes works. Square root property only sometimes works. Quadratic formula works every time. And I'll be completing the square also, even though it's not technically an Oklahoma standard anymore. I'll be doing it just as like a backup plan because it also always works. It can get a little nastier, which is why quadratic formula is the easier of the two. Let me make sure I got the entire page here. Is the easier of the two. So we started with this, evaluate the expression. This throws back to Algebra 1, where we have A and B and C and D, and then you just plug them in and figure out what they're trying to look for. So we just did some practice doing that. First one gave us 3 over 2 or 1.5. Now notice I have this crossed out, mostly because with all of this quadratic formula stuff, it could technically be a decimal, but the decimals are usually really gross. So instead we leave it in fraction form and we leave it with the radical still there and all that. But we just plugged all this in and figured out how to use our calculator properly and make sure we got the right answer instead of something crazy. This should look familiar. Ax squared plus bx plus c equals 0. So what we were using, and this should look familiar, with our factoring. Well, a, b, and c came from a, b, and c, and we knew how that works. Here's your quadratic formula. And this a, and this a, and this b, and this b, and this c, it's the same a, b, and c. But instead of plugging in here and trying to figure stuff out, we're going to plug in here, and we can let our calculator do most of the work for me. Now, my students get to learn a lovely song that I actually got off YouTube somewhere, so hopefully this isn't a copyright issue because I really have no idea where this came from. So give me 1 second, and I'll get the song ready for you. All right, so here we go. It's quadratic formula, this right here, but in song form. Hopefully you guys can hear it okay. And they're just singing that. It's to the tune of Pop Goes the Weasel. And I had that on a loop, and my kids got really annoyed with me, but I love it because once you figure out the song and figure out the formula, this test coming up, you'll be able to do it every time. Generally, this formula is not given. Sometimes it is, sometimes it's not. So here we go. X squared plus 5x plus 6 equals 0. We factored it. 3 times 2 gets me 6. 3 plus 2 gets me 5. X plus 3, x plus 2, set them equal to 0, and solve. So I showed them how the quadratic formula works. X equals negative b. And a lot of times people say x equals opposite b, as in take b and make it the opposite sign. So if you see positive, make it negative. If you see negative, make it positive. X equals opposite b plus or minus the square root of b squared, which we throw in parentheses, minus 4 times a times c all over 2 times a. We don't have a plus or minus sign in the calculator. We also can screw things up if we don't do this right. So if you paid attention, or if you're about to pay attention, make sure you go get the fraction at the very, very, very beginning. Let me show you some of the problems. If I try to do negative 5, and again, we don't have plus or minus, so we'll do it once with plus and then again with minus. Square root of b squared minus 4 times a times c. Fraction all over 2 times 1. Now you can already see that this does not look right. I got this kind of fraction here at the end, and that's not good. I really need all of this to be over 2a. So this is no good, because we should be getting like a negative 2 or a negative 3 is how we solved it by hand, and we're not. So this time we want to make sure we get our fraction first before we even type in the negative 5. Because if we don't, and we do negative 5 and then try to get a fraction button, like it ends up being really weird. So we want the alpha y equals, we want our fraction button first, negative 5 plus or minus square root of 5 squared minus 4 times 1 times 6 all over 2 times 1. Now, this also gives me a wrong answer, because this square root has to go over everything. If you don't, then it square roots this, and then it does this, and then it gets crazy. Please be careful that when you do this, negative 5 plus or minus square root 5 squared minus 4 times 1 times 6 all over 2 times 1. That's one of my answers, the negative 2. Now, how do I get the other one? Do I have to type in all again? Nope. Arrow up a couple times, highlight that, hit enter, and then just arrow back. To this plus sign. Nope, too far, too far. Just the plus sign, change it to minus, hit enter, because if you do anything else, your square root thing goes away. Negative 2, negative 3. So this works either way. Is that real quick? The discriminant helps us kind of figure out how many solutions we have. So b squared minus 4ac, not the square root, just b squared minus 4ac. This is called our discriminant. If we calculate this, and it is a positive number, we cross 2 times. Now, sometimes it's nice and pretty. Sometimes it's crazy decimals. If this is a negative, and we try to square root a negative number, this is where our imaginary solutions come in, and we got something like this. If this is 0, we have one solution. There's technically the same solution twice, where we touch. Because something plus 0 and something minus 0 is going to be the same. So when we do this, we went in this order. We wrote our quadratic equation, because the more you write it, the faster you remember it. Find our discriminant. That tells us what kind of roots we have. Then we can finish solving. So again, we need equal 0, so we move this over, and then we realize this can't be factored. So we jump here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Plug everything in. This is the next thing I want to calculate. Some of your cheating apps do it a little bit different, and we could just make that one number all at the same time. So we plug that part in the calculator and get 29. So I have negative 3 plus or minus the square root of 29 over 2 times 1, which is just 2. This is a prime number. Nothing can be factored out, and we're actually done. If you do this the way we just did and got decimals, you'd get this. And I don't like decimals because they're not exact. This is exact. This being a positive number, my discriminant being positive, make sure somewhere you have that we had 2 real solutions. On this one, same thing. Formula, plug in. B is already negative, so opposite B is now positive 6, plus or minus the square root of all this, which ends up being 20. 20 can factor to be 2 square root of 5. So I have 6 plus 2 square root of 5 over 2. 2, 2, and 6 can all be divided by 2 and becomes 3, 1. That's invisible, we don't have to write. Divided by 1, invisible, we don't have to write. So all we're doing is plugging in, getting the discriminants, simplifying this. Go back to 3.4 video with the complex numbers if you need a little refresher on how to simplify these radicals. But that's all we're doing. We're going to build this. We're going to build this, simplify a radical, and then see if those 3 numbers have anything in common. That was it for the first day. This next video is just going to have a bunch of examples on it.